agree with the reorientation that you indicated towards the end about how to think about confirmation theory. But I want to talk about like the other part, and that is to make a distinction between sort of the mathematics that is used to like analyze, like spectra in the old quantum theory, and the picture of the orbits that comes with it, right? Because like in going from the old quantum theory to like the new quantum theory, like in Umdeut, and we're going to hear a lot more about that later today, right? It's not a matter of discarding Newtonian physics, right? You're not. I like the slogan: we don't repeal Newton's laws, we reinterpret them, right? And so I'll talk a little bit more in the talk with Tony and me. We'll talk a little bit more about like these techniques coming from celestial mechanics in particular that turn out to be extremely powerful, like in analyzing all of this stuff. And these techniques carry over rather easily, like from the old quantum theory to the new quantum theory, right? I mean, the perturbation theory that you find, like in the Drei-Männer-Arbeit, like is sort of a descendant of, like the perturbation theory of celestial mechanics. So I like this. I've been working. So some people have been working on this metaphor on like how to think about developing the science as like arches and scaffolds. Yes. And so there's a famous paper by Gould and Lewitton called The Spandrels of San Marco, where the idea is that you build like an arch, and now you have 4 arches, and they're going to form a cathedral, and then by necessity you're going to have like spaces in between that you decorate very nicely. Those are called spandrels. And if you walk into the cathedral, you may mistake the spandrels for the sort of the main thing. And I think that's the sort of situation that you're in with the orbits. I mean, what's doing the work is like all this like beautiful mathematical machinery, and very naturally you come to think of it in terms of these orbits, and that turns out to be the bit that's wrong.
Yeah, I entirely agree, and for me it's a kind of a, how shall I express it, as a paradox or a surprise, how you take the mathematics and you transport it into a new theoretical framework, and you try and you seek the pictorial, you want to return the pictorial imagery, but it's wrong. It's not there. And yet, we talked about it yesterday, but you use it for didactic purposes, but it's misleading. And yet, the imagery is kept, but the mathematics is dealing differently with the object of study. So for me, it's a kind of a surprise that the imagery is being transported together with the mathematical technique. So thank you for the comment. Yes.
Thank you. Yes. Thank you for your lovely talk. I just have 2 remarks. One is when you gave this beautiful overview of the from Thomson to Bohr, I think we forgot Rutherford, because I think he is the one who first forcefully gave this idea, this picture of this planetary model when he was working on the nucleus. And the second was that I think what I learned again and again from this discussion is that the pictures have such a strong power, and that we need, as well, this community, they needed a picture to talk about, and this picture or this planetary model gave everybody to group around and to get. When we talk about things, we need a picture, and we need the idea that the other person has the same picture. And so a picture is always very important. We need it, but then of course it might be not really exactly right. Mm-hmm. And I think we can learn this from this period as well.
Thank you. As regard to the first note, I would like to remind you that Rutherford did not speak of a planetary model, period. Rutherford did not suggest a planetary conception of the atom. He discovered the nucleus. It was a great discovery. He spoke of the electron moving around, but he did not, you cannot find in his writings such an expression. He was very careful not to make this analogy. Of course, other people did it and used his results, but this is not Rutherford. Rutherford objected to this. I cannot say objected because he didn't use this analogy or metaphor or so. And it's so easy. I completely understand your inclination. It's sort of requested, you know. But Rutherford didn't do that. He was very careful not to make to make this analogy. And no, the answer is no.
I remember letters from Rutherford
To
against a certain picture of Thomson. I need to look it up.
yeah, please, by all means. To the best of my knowledge, you don't find it in Rutherford. And Rutherford, as experimentalist, he remained very close to the evidence, to the experimental evidence, and didn't sort of generalize the picture. And of course, he uses imagery, but he didn't appeal to the planetary model. And I think it's very striking because when Bohr, of course, Bohr consults Rutherford in 1913, and Bohr refers to Rutherford as having a model, but Rutherford didn't. Bohr was a poor historian, I should say, but Rutherford didn't have a model on that point. As to the pictorial, if you look at Reichenbach, Atom und Kosmos, it's fascinating to see that Reichenbach, the philosopher of science, is reluctant in 1927 to sort of discard the pictorial view of the atom, and he like the previous note of Michael Jan, he seems to willing or wanting to have a picture of the atom, and it's very surprising that the philosopher of science will not be critical of the transition that takes place and accept the theoretical underpinning now of the new theory that there is no picture. There is a mathematics, very sophisticated mathematics that is borrowed from celestial mechanics, but there is no picture. And Reichenbach expresses a similar point to what you are suggesting, which for me was very surprising. So imagery is very strong, and you try, as you pointed out. Sorry? Still today, yes, but I should stress, it's completely misleading.
We have 3 more questions. Arne?
Yeah, Giora, thank you for this talk. You know, there's some overlap with our work, and I liked very much how you related to questions of philosophy of science, so let me just focus on the historical part. So historians always like to have periodization and try to make it rather clear-cut. But my attitude, my perspective on this would be different, to say, well, there were competing views and competing strengths. For example, what Born writes in 1923, you can already find in 1904 with, probably surprisingly, Philip Leonard, who was discussing the model and said, well, then we go into the direction of 3-body problem, and then we have all these problems to solve it, and so on. So people already saw very early all the problems attached to it. And so my suggestion would be rather to say that there were, at the same time, competing views. And for example, as Helge Krake demonstrated, the planetary model was already there before Perrin, the middle of the 19th century, as a kind of speculation. So the planetary model for microcosm was around and is still around. Yes. It's only that some people then opt for it or try to discard it, to try to replace it. And in this sense, it is rather that we don't have phases, but some kind of competition of views. And probably the strongest point then is Heisenberg saying, forget about all these space-time pictures. It's questionable whether he really was successful to convince people to do so. And this leads me to my question. Don't you think that you have stressed so often that it's a misleading picture? Isn't it also a leading picture? Because it's so heuristic, it has brought about so much new results. And just think of semi-classics today, where we often like to reduce things that we can still, again, think in some kind of orbit structure. And in this sense, for example, Pauli tried to calculate this hydrogen molecule ion three-body problem, and he came to some solution which looked like an ellipsoid, which foreshadows the picture of an electron cloud, or this chemical orbitals. So there's much power in this imagery. Clearly, it's difficult to relate this now to truth, whether it's true or wrong, whether the mathematics is exact or not. So I would opt for, say, more discourse-like history of science in this respect.
Can I?
Yes,
Yeah.
yes, yeah.
Thank you for the rich note and the question. With respect to the comment, the periodization has to do, first of all, you're absolutely right. In the mid-19th century, or in the latter part of the 19th century, you have this planetary idea for the microcosm. But this does not include an electron. Of course, the electron was not discovered then. The point about Perrin, I think, is that he was the first to associate the electron in such a planetary model, which is, of course, this is for our periodization the first period. But recall that the first period has to do with just a very vague analogy, and it wasn't quantitative. It was you couldn't draw consequences from this analogy, and this is of course not the case with Sommerfeld, where the analogy actually is very productive and fertile, that you can actually draw quantitative results from the analogy, which was not the case in the first phase. So the third phase is actually the decline, the fall of the analogy, and I entirely agree with you about the imagery. But you know that one want to retain some kind of imagery, and it's very productive. But it seems to me that it goes in the direction of diagrams, or you know, it's like I don't know. I can think of. Some kind of modern techniques in quantum field theory where you have diagrams to help you, or with the high energy physics where you have, so the imagery is not, the imagery is of a different character, I would say. So it's not something natural like the planetary model that you would take. Oh, yeah.
Thank you. We have 3 more minutes. Christoph?
Yeah, I mean, again, from what Michel and what Arne was saying, also, you know, about the idea of misleading. It seems to me there was, how else could quantum mechanics have been found than through that analogy, right?
Yes.
And I think one striking example is the idea of matter waves, which was sort of really the only alternative idea that came up in the development of quantum mechanics. But there too, right, de Broglie's idea of matter waves was not enough, right? You needed Schrödinger to even formulate the idea of the wave equation. He needed the work of another astronomer, William Hamilton, to translate those orbits into the form of matter waves. So just having sort of a radical new idea ontologically will never be enough, right? And you know, I think Michel's talk about scaffolding is very apt.
Yes,
right?
it's very apt.
You needed the
Yeah.
structure that astronomical analogy gave you. Otherwise, you had no point to start. The same with vice versa.
Yes, I entirely agree. I accept this picture of Michel, that you know, the scaffolding idea. It's certainly very productive. What I'm concerned from historical philosophical perspective is the idea that, or is rather the historical fact that on the one hand, Bohr is absolutely aware, I mean, in writing, that there is a categorical difference between the stability of the planetary system, of a mechanical system, and the stability of the atom. He's explicit about it. On the other hand, he has confidence in the analogy. And this strikes me as an interesting tension in the production of a new theory. Thank you.
Okay, Clayton, one last word.
Very, very quickly. I certainly agree with you that early on Sommerfeld was very impressed with the planetary picture. But was he not also one of the first to back away from it when he introduced in 1920 his inner quantum number and emphasized there was no mechanical model underlying it? I mean, he took a lot of grief for it. He was accused of number mysticism and all of that. And my impression of Sommerfeld is that thereafter, he would certainly use mechanical models when he found them helpful and would entirely ignore them when he found that a more fruitful approach.
Well, with Sommerfeld, there's lots of didactic purposes in his writing, in the Atombau and the Spektrallinien, and that went further after the emergence of the modern quantum mechanics. And so, yeah, but I think you see, in 1923 he explores further the Keplerian approach, and he actually states explicitly the three Kepler's law with respect to the behavior of the atom. So, I think he took it rather seriously. This is the way I read it. Yeah. So.
Okay. Thank you very much.
Thank you. Thank you.
So, lots of stuff on the
Thank you. Thank you.